Hey guys, welcome to 11.5 Partial Fraction Decomposition. This probably seems like a lesson out of nowhere, considering we're just doing sequences of series, but you will see in the next section you will need this combined with sequences and series to get that. So kind of random, but kind of not. So partial fraction decomposition is, when you guys are trying to add two rational expressions, you have to get a common denominator and then, distribute to the numerators, and then you end up with one nice big rational expression. Today we're going to learn how to go backwards. If I give you the answer, can you come up with the two original rational expressions that you either added or subtracted to get here? So we're just going backwards. All right, so here's how it goes. There's kind of a lot of steps, so just the first one's probably going to be a little crazy, and then we're going to do two more. So first of all, again, here, now look, this is the same problem, so technically we know the answer, but I want to show you how to get it. So what you're going to do is first write out the two fractions, even though we don't know what they are. And let's factor the denominator. So let's see what our two denominators are. If you factor this out, you get x plus 4 and x minus 3. All right, so one of them has to be over x plus 4, and one of them has to be over x minus 3. And then we don't know what the numerators are, so one of them is going to be a, and one of them is going to be b. Now, let's pretend that you were trying to get a common denominator. Okay, so we're just going to focus on the numerator now. So if you were going to get a common denominator, wouldn't you multiply a by x minus 3 and b by x plus 4? All right, so we're going to do that. A times x minus 3 plus b times x plus 4. That would be our new numerator. And it's going to be equal to the numerator of the answer. So 5x minus 1. All right, so all we did so far, we factored it, we figured out those were our denominators, and then we kind of cross-multiplied to get the new numerators and then set it equal to that one. Now the whole point of this is to find a and b. And there's two ways to do it. And I think I'm going to show you guys this way. So kind of off to the side a little bit, we're going to plug in some values for x. And the first one I'm going to plug in is positive 3. All right, and the reason I'm going to do that is because when you plug in 3, 3 minus 3 is going to cancel, so we can solve for b. All right, so first thing I'm going to plug in 3 for all of the x's, and let's see what happens. We have a times, 3 minus 3 is just 0, plus b times 3 plus 4 is 7, equals 5 times 3 minus 1 is 14. And again, the reason I did that is because this is going to cancel, and then very easily we can see that b is 2. All right, now we have to solve for a. So to solve for a, I'm going to plug in a different value for x. This time I'm going to plug in the one that would make this 0. So that would be negative 4. And then I'm going to go ahead and plug in negative 4 for all the x's. So now we have a times negative 4 minus 3 is negative 7, plus b times negative 4 plus 4, which is 0, equals negative 4 times 5 is 20 minus, negative 20 minus 1 is negative 21. And again, the reason we did that, b times 0 is just gone. And again, easily we can see that a is going to be positive 3. Because a negative divided by a negative is a positive. All right, cool. We found a and we found b. Now we can just plug them in, and those are our original fractions. Okay, so final answer, a, so 3 over x plus 4 plus 2 over x minus 3. That would be your final answer. And if you look back up top, you'll see that we were correct. All right, so that's how you break an answer into its partial fractions. All right, let's try another one just like that. There is another way to do these, but I don't know. I'm going with this way. I think it's pretty good. All right, so this one, write the partial fraction decomposition of this guy. So let's start by factoring the denominator. It's x minus 3, x minus 2, because that will tell us what our fraction denominators will be. So one of them is going to be over x minus 3, and one of them is going to be over x minus 2. And again, let's call one a and one b. And then same thing as before, let's pretend we were trying to get a common denominator, which means the a would be multiplied by the x minus 2, and the b would be multiplied by the x minus 3. And then that's going to be the new numerator, so this is going to be equal to the numerator of this guy, which is x. And here's where we get fancy and we plug in some strategic x values to find a and b. And you want to pick ones that are going to make it cancel. So I'm going to start by plugging in x equals 2. So we're going to end up with a times 2 minus 2 is 0, plus b times 2 minus 3 is negative 1 equals x. And a times 0 cancels. Oh, sorry, I forgot to plug in 2 for x. And then 2 divided by negative 1 ends up being that b is negative 2. Okay, so that's great. And now we're going to plug in a new value of x to try to find a. So this time, I'm going to plug in x equals positive 3. All right, so go ahead and plug that in. It's going to be a times 3 minus 2 is 1, plus b times 3 minus 3 is 0. That's the whole point. And then x this time is 3. So this one cancels. And if you solve for a, 3 divided by 1, a is just 3. All right, so once you find a and b, you are good to go. We'll just plug them back in up here. So final answer, 3 over x minus 3 plus negative 2 over x minus 2. And that's it. So if you were to add these together, you would end up with this sum. All right, now, just when you guys are feeling confident, I'm going to throw a harder one at you. Let's try number 2. So when you guys factor the denominator, let's see what we get. We're going to start by pulling out an x, and then you get x squared minus 2x plus 1, and then that can actually factor further, x minus 1, x minus 1, which we technically could write as x times x minus 1 squared. Okay, that was just factoring the denominator. Now here's the bad news. When you guys have a repeated factor, it's going to be a little bit harder. All right, so one of them we can do is a over x. All right, that's that one. The second one, see how there's a repeated x minus 1 factor? One of them has to be over just the x minus 1, but then the third one is going to be over the repeated x minus 1 squared. That's what makes these harder. Okay, so whenever you have a repeated factor, you need the single factor, and then you need another one with the double factor. So you end up having an a, a b, and a c. All right, so anytime there's a squared, do the single and then the squared. Now, if it was cubed, you would then have a d with the x minus 1 cubed. All right, but everything else now is the same. So if we get a common denominator, the a would need the x minus 1 squared. The b would need the x and another x minus 1. And then the c would need the single x. And if that's all the numerator, this is going to be equal to x plus 2. All right, so that's just getting a common denominator. No big deal there. All right, now we're going to do our strategic x's. And I'm going to start with x equals, let's do 1, because that's going to make the a term and b term drop out. All right, so if you plug in 1, you get a times 0 squared plus b times 1 times 0 plus c times 1 equals 1 plus 2, which is 3. Now, anything with a 0 is going to cancel. And again, very easily, you can see that c is equal to 3. All right, let's do it again. This time, let's plug in x equals 0, because that's going to make some stuff cancel. So if x is 0, you have a times negative 1 squared plus b times 0 times negative 1 plus c times 0 equals 0 plus 2, which is 2. Now again, anything with a 0 cancels. This time it's those two. And 2 divided by 1 would give us a equals 2. And then for the last one, we can plug in a and c and any new x that we want, besides 1 and 0. So I'm going to do 2. Okay, so for this last one, to find b, we'll plug in c is 3, a is 2, and x is 2. And we'll be able to find b. All right, so we got a, which is 2, times 2 minus 1, which is 1 squared, plus b is missing, x is 2, times 2 minus 1, which is 1, plus c, which is 3, times x, which is 2, and then 2 plus 2 is 4. Okay, so we plugged in a lot of stuff there, and now you guys can find b. So what is this? 2 plus 2b plus 6 equals 4. And then if you add like terms, this gives you 8. If you subtract 8 over, you get 2b equals negative 4, so b ends up being negative 2. And then final answer, I'm out of room. If you write all the fractions with them plugged in, it's going to be 2 over x plus negative 2 over x minus 1 plus 3 over x minus 1 squared. That's your final answer. Oh, you can't see that. There you go. All right, that's partial fraction decomposition. Thanks for watching.